This is the second part of the video series. In first part, we discussed about the basic terms related to curves. In this part, we are going to discuss about the polygons in general. We will try to understand the definition, terminology, and types of polygons, along with some other basic concepts like the diagonals of the polygon, the sum of interior and exterior angles. In last video, we talked about the simple curves like the one in figure 1. A curve is a line which changes its direction at least once. That means if there is a slight curvature in the line at any point, that line is a curved line. Now, consider figure 2. In figure 2, we have two different line segments. One is AB and second one is BC. In line segment AB, there is no curvature, there is no bend in AB, so AB is a straight line segment. Same is the case with BC. But if we consider this from point A to point C as a whole, then we can observe there is a bend at point B. So when we are taking it from A to C, there is a curvature at point B. So we see we can have a curved line which is made up of straight line segments or straight lines. When we adjust or combine two straight lines, we get a curve, and that curve will be always open. There is no way to get a closed curve by using only two straight lines. But when we have three different line segments or three different lines, it is very simple to understand. We can get a closed curve. You will not always get a closed curve by using the straight lines in whatever manner you want. It depends on your adjustment of lines. It simply means that three lines can be adjusted or arranged in such a way that we can get a closed loop or a closed curve. And that closed curve we are getting is called as triangle. As it can be seen in the figures, AB is a straight line segment, BC is a straight line segment, and AC is a straight line segment. And the three line segments are arranged in such a way that we are getting a closed loop. So this closed loop is the triangle, and triangle is considered as the least polygon. It marks the beginning of the polygons. Now, to define polygons in general, we simply say polygons are closed planar shapes with three or more sides. To get a polygon, we need at least three sides. We need at least three straight lines which can form a closed loop, which can form a closed figure. So, the triangles are the least polygons. They are planar because they can be drawn on a plane. They are obviously two-dimensional objects. Let's talk about the basic terminology that will help us in better understanding of polygons. First, we have the vertices. Vertices are simply the corners of the polygon. For example, we have a triangle ABC, which is the least polygon. In this triangle, we have three corners, A, B, and C. These corners are called the vertices of the triangle or vertices of the least polygon. Then we have the consecutive sides. Consecutive sides are those sides which have a vertex in common. Consider again, in triangle ABC, AB and BC are two straight line segments connected at point B. B is the common vertex to both the sides. So AB and BC are consecutive sides. Similarly, BC and AC are connected at point C. So BC and AC are consecutive sides. In fact, in a triangle, all the three sides are consecutive to each other. But that is not the case for other polygons. For example, we have a polygon here which have four sides. It is called as the quadrilateral. In this quadrilateral, if we consider vertex C, then AC and CD are the two sides which are connected at point C. So AC and CD are consecutive sides. But AC and BD are not consecutive because there is no common vertex between the two sides. They are the opposite sides of the quadrilateral. Third one is the diagonals. Diagonals are the line segments joining the non-consecutive vertices. Like we have the consecutive sides, we have the consecutive vertices as well. Consider the quadrilateral ACDB. A and C are the two consecutive vertices. C and D are two consecutive vertices. D and B are two consecutive vertices. So, when we say non-consecutive vertices in this figure are C and B, A and D. So, if we have a line segment that joins the non-consecutive vertices of a polygon, then we say that line segment is a diagonal. Generally, we have two types of polygons. Number one is the regular polygon. Number two is irregular polygon. A regular polygon is a polygon that is equiangular, that is all the angles are of equal measure, and equilateral, that is all the sides are of the same length. For example, we have a triangle ABC in which all the sides are equal to 12. So all the angles will be same because we know if in a triangle all the sides are equal, then all its angles must be equal. So it is an equilateral triangle. Also, it is an regular polygon. Another example is of a pentagon. A pentagon is a polygon in which there are five sides. And if all those five sides in a pentagon are equal and all its five angles are also equal, then it is called as a regular pentagon. Number two is irregular polygon. An irregular polygon is simply a polygon which is not a regular. That means if we have a polygon which does not have the properties of a regular polygon, then that polygon is simply an irregular polygon. For example, we have the triangle in which two sides are equal to 5 centimeter and the third side is equal to 3 centimeter. So we can easily see that this is not an equilateral triangle. So if all the sides are not equal, then it is not a regular polygon. So it is simply an irregular polygon. Same is the case with the second figure in which we have different sides of different lengths. Now to name or classify a polygon, we see how many sides are there in that particular polygon. A polygon with n sides is called n-gon. Gon means the sides. So if a polygon has n sides, then it is called n-gon. So depending upon the sides, we give different polygons different names. For example, If the polygon has three sides, then it is called a triangle. If it has four sides, it is called the quadrilateral. If it has five sides, then it's called the pentagon, and so on. You just need to remember some of the names. Now we have sum of interior angles of a polygon. Interior angles are those angles that lie inside the figure, that lie inside the polygon. And sum of these interior angles of any polygon with n sides is always calculated as n minus 2 into 180. Consider this pentagon. In this pentagon, we have n equal to 5. N stands for the number of sides. So n is equal to 5. Substituting this n equal to 5 in this formula, we get the sum total of all the interior angles equal to 540. That means the sum of interior angles of a pentagon is always equal to 540 degrees. And if you have to calculate each interior angle of an equiangular angle, that means a regular polygon, then you can use this formula n minus 2 into 180 divided by n, or simply 180 minus 360 divided by n. For example, in this polygon, each interior angle will be equal to 108 degrees. Now, if you count one exterior angle at each vertex of a polygon, then the sum of the measure of exterior angles will be always equal to 360. Doesn't matter how many sides are there in a polygon, the sum of all the exterior angles will be equal to 360, provided if you are considering only one exterior angle at one vertex. For example, we have a triangle. We have three exterior angles, x, y, and z, each one at one particular vertex. Then the x plus y plus z, that is sum of all the three angles, will be equal to 360. And if that polygon is a regular polygon, that is equiangular polygon, then each exterior angle can be calculated by using 360 divided by n. As for this triangle, each angle will be equal to 120 degrees.